All right, question number 9. It says W, X, and U are points on the circumference of a circle. TV is a tangent to the circle at U. Then we're told that what UW is a diameter of the circle, and triangle WXU is isosceles. So he's saying things that we can see for ourselves. Using appropriate theorems, state 3 reasons that explain why the measure of angle Z is 45 degrees. The way I interpreted this is like you need to, in 3 steps, determine the size of angle Z. And at each step, you're going to give a reason for the step. All right, that's how I interpreted it. So we want to find out what is angle Z. Now, what I'm going to do to answer this, I'm going to find this angle and then use that knowledge to determine what is the size of angle Z. So the first thing I'm going to tell the examiner is that this angle here at X is 90 degrees. So I'm going to tell the examiner that WXU, angle WXU is equal to 90 degrees. And the reason for that is that angle WXU is an angle in a semicircle. And the angle in a semicircle measures 90 degrees. So that angle is 90 degrees. This triangle is isosceles. And for an isosceles triangle, the 2 equal sides meet at the apex. Opposite from the apex is the base. And the 2 base angles of an isosceles triangle are equal. So next I want to find the size of angle theta. And I would say theta plus 90 degrees is equal to 180 degrees. And the reason for that is that these are the interior angles of an isosceles triangle. They are the interior angles of an isosceles triangle. So 2 theta plus theta is 2 theta would be equal to 180 minus 90. 2 theta would be equal to 90. You divide both sides by 2, and we get that the angle theta is equal to 45 degrees. Next, I will tell the examiner that this entire angle here is 90 degrees. That angle WUV, I would tell the examiner that angle WUV is equal to 90 degrees because the radius at point of contact is at right angles to tangent. The radius at the point of contact is at right angles to the tangent. So if the entire angle is 90, and the angle theta is 45 degrees, it means therefore that what Z would be equal to 90 minus 45. Z is 45 degrees. So this is how I interpreted the question. The examiner is basically saying to me that in 3 steps, I need to show that the angle Z is 45 degrees. And for each step, I need to give the reason for the step. So that's how I interpreted the question. All right, B part of the question now. We're told that the diagram below shows a circle with diameter KF. Line EFG is a tangent to the circle at F, and F H, K, and J lie on the circumference of the circle, where to, by showing each step of, in your work, where appropriate, find the value of each of the following angles. So we're going to show, we need to show each step in our work where it is appropriate. We need to find the size of angle X. Well, that one is actually straightforward. Angle X is actually equal to 56 degrees. There are angles in the same segment. All right. So remember, angles at the same segment, they start at the same point at opposite ends of a chord, start at F, end at H, and the angle is formed at K and J. Those two angles are at the circumference in the same segment. They're called angles in the same segment, and they are equal. Angles in the same segment are equal. We need to find angle Y. All right, angle Y now. All right, I think I showed this to you last time as well. All right, for angle Y, this is what we have. All right, I don't know. I think this is the quickest step to get to it. This is angle Y is here. We have X here, which is, this is K, and X is here, which is 56 degrees. And the angle here, do we have that angle? Yes, this angle here is 19 degrees. Now, you see the angle Y, it's actually equal to 56 plus 19. Angle Y is equal to 56. You didn't have to do it this way. You could have find this angle first, and then you could find this angle using the interior angles of a triangle, and then subtract that from 180 angles on a straight line. But the angle Y is equal to 56 plus 19. The reason is that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So the angle at Y is actually equal to, when you add that, what you get? 75? The angle at Y is 75 degrees. It's 75, yeah. All right, turning the page. All right, so this would be the part of the question that would give the most challenge. However, the first part is doable, providing that you understood it. I think one student actually did, and I wrote on her paper, very good, because I didn't expect her to see it. It says the diagram below shows 4 points, P, Q, R, and S on level ground, where pillars will be placed to mark the outline of a foundation. So P, Q, R, and S is where they're going to put pillars to outline the foundation, outline a foundation. We're told that there is a vertical pole, RT. So we know that the pole is at R because the pole is RT. So it's a vertical pole RT at R. From Q, the angle of elevation of the top of the pole, T is 21 degrees. So let's see if we can put in this pole. The pole is RT. And the person who did this actually did this very well. I was very proud of the effort. All right, so we have our vertical pole, RT. Now, so this is R and the top here is T. We're told that the angle of elevation of the top of the pole, T, is the angle of elevation. So from Q, actually first from Q, that elevation of the top of the pole, T is 21 degrees. So someone is at Q looking up at T. How do I know that? I know that because the person talk about angle of what? Elevation. All right. So RT is vertical and RQ is on the horizontal ground. Ladies, gentlemen, the angle between horizontal and vertical, that angle is 90 degrees. So that angle there is 90 degrees. This is the line of sight. The angle of elevation is the angle between the horizontal and the line of sight. This angle is 21 degrees. We're asked to find the height of the post. So that is the post TR, let's call it X. Now, X is in front of the angle 21, so it is the side that is opposite. And where the 153 is adjacent. Now, the trig ratio that includes opposite and adjacent is tan. So I'm going to say that the tangent of 21 is equal to opposite X over adjacent 153. Now, if I have one fraction is equal to one fraction and I want to get rid of the fraction, I'm going to cross multiply. So 1 times X is X is equal to 153 times the tangent of 21 degrees. So X, which is the height of RT, the height RT is equal to 58.7 meters. All right, so you just put 153 tan 21 degrees into your calculator and press equal, got 58.7. Next, we're told that given that the length of QS is 135, we're to calculate the perimeter of the foundation. We're going to calculate the perimeter of PQRS. So this is the part that should give you a problem because it requires knowledge that you don't have yet. All right. So we're told that we're given a certain length a while ago. The length QS is 135. So QS is 135 meters. 135 meters. To get the perimeter, remember perimeter is the length of the distance around. I need to calculate this distance y. To calculate that distance, I'm going to have to apply something called the cosine rule. So that is what you have not learned yet. The cosine rule says c square is equal to a square plus b square minus 2bc cosine c. That's the cosine rule. C square is equal to a square. It's sort of like Pythagoras theorem, but it isn't. C square is equal to a square plus b square minus 2bc cosine c. Now, for this formula, a and b are the two sides. So this is a and this is b. And this is c, look at c. And the angle between a and b is the angle c. So the angle c in the formula is 29 degrees. A is 83, B is 135. We are using the cosine rule. So this is y, which is what we want to find. Y square is equal to 83, that is a square, plus b, which is 135 square, minus 2, sorry, the formula is not correct. All right, I'm going to correct it. This is where the formula is wrong. All right, and this should be AB. All right, good. So minus 2AB, so it's minus 2 times A, which is 83, times B, which is 135. The cosine of C, which is 29 degrees. C in the formula is the angle between A and B, which is 29 degrees. Now, I would have just put the entire thing in my calculator, 83 square plus 135 square minus 2 times 83 times 135, cosine of 29. You put that in a calculator, you get y square is 5,513.7724. The opposite of square is square root. So y, which is PS, is equal to the square root of 5,513.7724. This works out to be 74.3. And so the perimeter, which means distance around of the foundation, will be the sum of all the sides. So that will be the easy part after I apply the cosine rule. 74.3 plus 83 plus 153 plus 110. It has 4 sides. When you add them together, I got 420.3 meters. All right, and that is the end of the question.